So you guys, we did categorical data. We displayed categorical data with what kind of graphs? Bar graph, pie chart. And then the bar graphs had a couple different kinds. There was like a side-by-side, and there was a segmented bar graph and a mosaic plot where they changed the width of the bottom part. All right, so now we're going to do quantitative data. There's a bunch of types of graphs for numerical data. Today we're going to do dot plots and stem and leaf. Hopefully that warms your 7th grade heart, you know, when you did a stem and leaf back in the day. You're like, I think I can do this. Hearts are warmed. All right, good. How good was the 2012 U.S. women's soccer team? With players like Abby Wambach, Megan Rapinoe, and Hope Solo, the team put on an impressive showing en route to winning the gold medal at the 2012 Olympics in London. Here are the data on the number of goals scored by the team in the 12 months prior to the 2012 Olympics. I don't think you need to write these steps down because this is like real easy, okay? How to make a stem and leaf. You are going to make a number line. Draw a horizontal axis, right? You're going to go from the lowest number to the highest number. You do not have to include 0 on this one, right? Just like start with your low to your high. All right, scale it. And then you're going to put a dot on the dot plot for like each goal, number of goals scored per game. The main thing you want to remember on this is you do have to label your axes, okay? So even though there was no title in the bar graphs, there's kind of a title on this, or if you want to think of it as just labeling your x-axes, all right, number of goals scored. So there was one game where they scored 0 goals, there were 4 games where they scored 1 goal, okay, all the way up to 14 goals. That team was bad. Okay, I would not take notes, but that is what a dot plot looks like, okay? Everyone feel they can make a dot plot? Great. Now this you probably don't know, and you will need to know for the AP test, so I would write this part down, all right? Write down SOX. And what SOX means is when they ask you to describe the distribution you are going to do SOX to remind yourself of the 4 things you need to write down. So that acronym stands for shape, outliers, center, spread. All right, shape, outlier, center, spread. Those are 4 things you need to talk about on the AP test if they say describe the distribution. All right, there are 3 types of shapes that we will focus on. I guess I'll put the other ones in there just in case. But there's the big 3 here. All right, your distribution might be skewed left. The way you're going to remember this is it looks like your left foot, right? That's like your big toe and your little toes going downward towards the left, okay? That is skewed left, unless you have weird block feet where they're all the same size, all right? But it's pulled towards the tail. Well, that could still be okay, because look, that could be okay. You're set, that's still skewed left. Yeah. All right, good. And now I got a skewed right graph. So your right foot, or if you just want to think that it's pulled towards that tail, wherever the tail is, okay, on the right-hand side, that's skewed right. And then we have our one that's kind of like just in the middle, our bell shape. Sorry, this isn't very good, but okay, that's a little better. This one you're going to say roughly symmetric. We have 2 more weird ones that you're not going to see as often, but I might as well throw them in there. This is what my toes look like, okay? It's just like a block across, and it's wide. All right, anyways, uniform is like straight across, okay? All uniform the same size. I know, okay, it's weird. And then we've got one more that they like to throw in there, and this one is I ran out of room. This is one word, but bimodal. That's one word. Bimodal. 2 modes, 2 peaks, Okay, that means there's 2 peaks. I'll show you an example momentarily. All right, now when you do SOX, you're going to write sentences. Unfortunately, you can't just write S, skewed left. And if you use the acronym, they'll count you off. So you have to use a whole sentence, and you have to say the shape of the distribution of goals scored by the U.S. soccer team. You got to throw all that in. And that word you're looking for is distribution. The shape of the distribution of goals scored is, what do you guys think? Way to go. All right, so if you were to draw this, the tail is like pulled way over here towards these guys. Okay, that is definitely skewed right. And you want to use the whole sentence. Now we would ask ourselves if there's any outliers. So the O stands for outliers. Now, if there are no outliers, you actually don't have to say anything, okay? But if there are outliers, you have to talk about them. So it's how you feel in your heart for now, because we're going to learn a formula eventually. But do you guys think there's outliers? Oh, yeah. Yeah, these 2 right here. Look how far away these points are from the rest of the data. Those are definitely outliers, and I would mention them. There appears to be 2 outliers. That's how the sentence starts. There appears to be 2 outliers. We'll test for those eventually, okay? But for now, there appears to be 2 outliers. All right, for center, we're going to learn a bunch of measures of center, but for today, we're going to do median. We also have mean and mode, all that stuff, but we're going to do median today, okay? So the median is the 50th percentile. So you're going to count like half of the dots. So first of all, you have to know how much data you have. All right, how much data do we have? So you would count all of these numbers, and there are 25 games that they played in right here. And so if you have 25 data points, that is an odd number. So I need to find the center number. We split it in halvesies, and I would do it like this. 12 with 1 in the middle, and then 12 over here. There is a center number. So I always split the number in half in my head, and I'm like, oh, I'll just round down to 24. There is a middle number, and then there's 12 on the other side. So that means that the spot where the median falls is in what spot? The 13th, okay? It's in the 13th spot. Great. So I cannot count with this data because it is not in order from least to greatest, but I can use my stem plot to count. And yes, you guys have to watch me count because it's actually hard sometimes, all right? So you have to know how to count. You want to go left to right, and you want to just work your way up each of those dots. So we're going to count to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the middle dot. You would want to make sure that there are 12 on the left and 12 on the right, and that's the middle dot, okay? And then I would say the median is 3 goals scored. So the center of the data is about 3 goals scored per game, right? All right, what if there was 24 numbers? If I split it in halvesies, what would that be? 12 and 12. So that would actually mean there's not a middle number. What do you have to do? Average the 2 middle numbers, right? So cut it in half. If you get 4 and 4, you still have a middle number of 4. If you have 4 and 5, then the median's 4.5. Average the 2 middle numbers, okay? All right. Oops, it was 4. All right, but you're going to have to write a sentence. You can't just do that, all right? And then spread. So for spread, you can either do range, or we're going to learn about IQR in this class. IQR is the quartile 3 minus the quartile 1, which is the center of the top half of the data minus the center of the bottom half of the data. But we're not going to do that today. Range is like real easy, so we're just going to do range today, okay? And then eventually we'll do standard deviation later, all right? But for now, we're going to be like the range of goals scored by the U.S. women's soccer team is from 0 goals to 14 goals, okay? So spread, think range or IQR. All right, let's do a few more just to practice. Oh, this is how much they wrote. for their answer. You don't have to do that. Oh, they'll use this word vary, like for range. Okay, varies from 0 to 14. All right. Here's some more of these. Like I just showed you all those shapes, but it could be a histogram as well. So you could still say roughly symmetric, skewed left, skewed right, uniform, bimodal. Okay, just in a histogram form. Okay. So let's try, we roll a dice 100 times. Actually, we roll 2 dice 100 times, and we add them together, and we put the sum, and we make a dot plot, okay? So what would you guys say the shape of the distribution of the sum of 2 dice is? Roughly symmetric. Write the whole sentence, okay? Are there any outliers? No, there are no outliers. No, nothing is far away, right? You guys looking at this one? By the way, don't overthink roughly symmetric. If you're not sure, it's roughly symmetric. Okay? Don't be like, how many modes? 27, 15 modes. Don't do that. It's probably just roughly symmetric. Okay? Now for the center. If we rolled the dice 100 times, there are 100 dots on that dot plot. So where would I split it to find the median? 50, 50. And yes, you have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 26, 25. I don't know. Okay. Wait, it's supposed to be 7. I think I messed up. Okay, whatever. So there's 25 dots on the left and 25 on the right. Okay, you should count better than me and use your pen. It's really actually kind of hard, okay, but you got to count 25. And yes, it is 7, so our median is 7. All right, and then what would you guys say for the spread, or how much it varies by? 2 to 12, I agree with you. Okay, this is scores on a quiz. What would you guys say the shape of the distribution of the scores is? I agree with you. All right, so this guy right here is skewed left. Excellent. And are there any outliers? No. All right, and then you'd have to count all the dots and find the middle number, which I did in the last class, okay? But I won't make you guys do it. It's somewhere in the, what do you guys think? 90. It is 90. All right, but you would want to count halvesies and halvesies, all right? And you could find your median. And what would you guys say the range is? 70 to 100. Did we do outliers? Someone thought there was. This would be no. I would say no outliers. Those are pretty evenly spaced apart. Nobody's like super far away, but like a 20% would definitely be an outlier, all right? We would be concerned. All right, this is another example of bimodal. All right, if it's a real obvious one, it's bimodal. Otherwise, it's roughly symmetric. Okay, I've never seen multimodal, but it's like, woo, so many modes. Okay, comparing distributions. So now we're going to use comparison words. That's the biggest part. Instead of doing one graph, we're going to do 2 distributions and compare them. So if it says compare the distributions, you still need to do SOCs. The only thing you have to add is you have to use words like more than and less than. Okay? And the only ones you're really going to do that on are the median. Well, I guess that's center, the measure of center, and the spread when you do SOCs, which is the range. All right? We want to say which one is bigger than the other one, more so than even saying the exact data point. But you could say both, okay? So what do you guys think the shape of the distribution of household size? So like they asked a bunch of people, how many people live in your house in South Africa? All right, what is the shape of this distribution? It is skewed right, okay? Are there any outliers? Someone lives with 26 people. Yes, that is an outlier, okay? And then you would have to find the median. And again, I always look and see, did they tell me how many they asked? They asked 50 people, so that means there's 50 dots, right? So if I split 50 in halvesies, there should be 25 on the left and 25 on the right. And I'm going to make you watch me count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, the median is in between these 2 points that are 6 and 6. So the median is 6. Okay, so that means that the typical number of people living in a house is 6 in South Africa. Okay, now we're going to do the UK. What would you guys say for the shape of that distribution? Yeah, it's weird, and so it's probably roughly symmetric. Okay, this is roughly symmetric, even though it's like a little bit odd looking. All right. And then are there any outliers? No, no outliers. I agree. They're all pretty close together. And then we would count yet again. There are 50 dots. We would find between 25 and 25, right? And it's going to be right here somewhere in the 4s. I'll just pretend like you guys, I counted because I know you don't want to watch me count, okay? And we will get 4 for our median. Now, it's way more important if you actually say in South Africa, the center of the distribution, which is the median, is 6. And in the UK, the center of the distribution, or the median, is 4 people living in a household. You will not get full credit because what word did I not say? More or less. It's really dumb, but you have to say that, okay? So you have to state there are more people living, typically, in a household in South Africa based on the median, okay? The median is larger, even though it's real obvious that 6 is greater than 4. You're like, but I literally said 6 and 4. You have to use the word more than or less than, okay? All right, for the range, which one has a bigger spread or varies more or has a bigger range? Yes, way bigger range. And we could say it goes from 3 people in a house to 26, whereas in the UK, it goes from 2 to 6. All right, so a smaller spread, and you have to use the words more than or less than. This I just told you. Tip, AP exam tip. All right, this is last year's data. How much time do you spend on Snapchat? We're just going to review how to make a stem and leaf plot in case you forgot. This is a number of minutes spent on Snapchat. So 20, and we go all the way up to 144. I know, like that's a lot of time. All right, so we are going to have a stem of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, you can have 2 digits for the stem. You can only have a single digit for the leaf, okay? All right, and then you're going to go 20, 20, 24, 25. So it looks like this, 0, 0, 4, 5. There are no commas, all right? No commas. And you want to line your numbers up because we're actually going to look at the shape of the distribution here. You guys are like, I literally did this in 7th grade. Why are you making me do this? I know, I'm sorry. There are no 3s, okay? So you have to have the 3 there. You can't skip it, but we don't put anything in the 3s. And we go to 40, 45, 45, 45, 40, 45, 45, 47. And notice I tried to kind of line them up nicely. Okay, there's nothing in the 50s. Nobody was in the 50 minutes, but I do have a 60, and I have a 65 and a 68. And then I have a 72 and a 74. And then I have a 90. And then I have a 110. And then I have a 120 and a 120. Oh, and then I have a 144. Okay. What is the shape of this distribution, even though it is sideways? Yes. How do I know right or left? Because it can be confusing. You want to think, is it pulling towards the higher numbers or the lower numbers? And the higher numbers would be skewed to the right. All right. So this guy right here, skewed right. Why is that? Because some people spend 2 hours on Snapchat, and that's weirder than the rest of the people. Okay. And then you would find the center number, again, by counting. And when you count, this is in order from least to greatest. So you're going to start here to count your middle numbers to find the center of the data. All right, and then you can say the spread and all of that. Don't skip any stems, even if there is no data value. I just demonstrated that for you. Don't skip like the 3s, okay? Arrange the leaves in increasing order. We know that. Oh no, I did not provide a key. Okay, you'll lose credit on the test. So let's go back and do a key. All right, somewhere in here you have to write key. And then you pick any number like this 72 right here, and you do 7-2, and you write 72 minutes. Like you say what it means. Because it could be a decimal, or it could be in thousands. All right, there could be like some notation. So pay attention to the key and the notation. And don't forget to make a key if you do a stem and leaf on the test. Don't use it if it's a lot of numbers. Bad news bears. It just does not work, okay? So we'll probably do a histogram for that, and I'll show you how to do that later. You don't want to have really any fewer than 5 stems. If you have too few of stems, you cannot tell the shape of the graph. All right, so what you should do is split it. Like, let's say everybody was in the 20s, 30s, and 40s on your Snapchat. Okay, I asked you guys all, and there was only those numbers. Well, we would go like this, and I would split it 2, 2, 3, 3, 4, 4. That way I have more than 3 stems. What would be in this range of numbers so it was even? 22, 24, because how many numbers is that? Okay, 5 numbers. And then I would go 25 to 29, because how many numbers is that? 5. So as long as it's like even, okay, you're good to go. And then this would represent the 30 to 34, and this would be the 35 to 39, etc. All right, so split it evenly, and then you can actually determine the shape, and it looks a lot more reasonable. All right, if you split stems, be sure that each stem is assigned an equal number of possible leaves. That's what I just said. All right, and then you might want to round. If you're like, hey, let's do a stem and leaf for everyone's salaries in this school, we should probably round it to 52,000. And then do you not want to do a stem and leaf with like thousands? That's gonna be a lot going on. So you can just go like this, and then what's your key gonna say? In thousands, okay? So this would represent 52,000, because that would be real annoying to have a bunch of digits. All right, this is a number of shoes owned by males and females, and you're like, why are we doing this? You have taught us enough. Because it has ones on the left, and it is kind of weird when they're on the other side. So you can do a back-to-back stem and leaf to compare your data. So for example, this person right here, for the males, has how many pairs of shoes? 10. But for the females, what is this number? It is 13. Good job. And what's this number for the females? 57. You got to read from the inside out, which is annoying. All right, what would you guys say is the shape of the distribution for the males? It is skewed right. It's pulled towards the higher numbers. How about the females? It's actually skewed right, just less so. And why is it skewed right? Because you're like, I know, it looks left. Because it's towards the higher numbers, so it's pulling it up. Okay, so it's skewed right, towards the higher numbers. All right, there's probably no outliers, and we could find the centers by counting again, and we could do our range, okay? The only reason I'm doing this one is because you definitely want to pay attention to the key, which is a decimal, if you can't see that. So this actually represents the number of people over 65 living in Alaska. Apparently, elderly people don't like Alaska because only 6.8% of them are over 65. All right, that's all it's asking about. But you could gather some data. Just pay attention if there is a decimal, okay? All right, you guys. No in-class worksheet. These are your 6 problems. I took out the worksheet because it's kind of a long lesson.